Hi everyone and welcome to the internet. What we're going to be doing in today's chemistry lesson is having a look at filtration and crystallization. So hopefully by the end of today's lesson you're going to be able to describe how to carry out both those processes and explain how they work. To start us off though, we've got a couple of questions based on our previous lesson, so have a go at answering these two questions in your book. So question 1, define the term pure. Question 2, describe how you can test the purity of a substance. So I'm going to give you about 3 minutes to have a go answering those in your books. Let's mark those answers then. So for question 1, hopefully we wrote down that a pure substance contains only one chemical substance. So if you wrote that down, give yourself a tick. Question 2, how do we test for a pure substance? Then the first mark is for saying we heat the substance slowly. Second mark if you said to stir it as it melts. Third mark, record the temperature at which it melts. And the final one is for pointing out that if this melting occurs at a single temperature, we have a pure substance. So total of 5 marks available to us across the 2 questions. Add up your score and give yourself a mark out of 5 in your books. Before we can really get stuck in with these processes, we need to remind ourselves about a few keywords and what they mean. So what I've got for you on the screen are 5 key terms, and what I want you to do is write me the definition for each of those 5 terms. So I'm going to give you about 5 minutes, which is a minute for each of them, so plenty of time. Have a go at writing me a definition for each of the 5 terms on the screen. What I need you to do then is tick any of these that you've got right, and if there were any that either you didn't know or you've got wrong, make sure you have the correct definition written in your books. So when we're talking about a solution, that is the solute dissolved in the solvent. The solvent is the liquid that the solute is dissolved in. The solute is the solid that dissolves in the solvent. Soluble means that the substance will dissolve, and insoluble means that the substance won't dissolve. So I'll leave these up just for about another 30 seconds, but if you're missing quite a few, I'd suggest you pause the video now so that you've got a chance to write those proper definitions. If we think about this process of dissolving, because we mentioned it a fair bit in those key terms there, then what we actually see happening is that when a substance dissolves, the particles separate and become completely mixed with the particles of the solvent. Now the key thing here is that they're not chemically bonding, they're separating and mixing. What I'd like you to do is write down the top sentence and then have a go at answering the two questions underneath in your books. So I'm going to give you a couple of minutes to do those two things for me. So the first point, no, not all solvents will dissolve all substances. And there's a range of different examples you could have given here, but the one I always like to refer to is nail varnish. Now, nail varnish is obviously a substance that we put on our nails, at least some people do, and what we actually find is when you wash your hands, then it's not going to dissolve. So water is a solvent, but it doesn't dissolve nail varnish. The first process we're really going to look at then, and the first one of these separating techniques that you need to know, and not just the basics of it, but how it works, describe how to do the experiment, and what we'd use it for, is the process of filtration. So what I've given you on the screen then is a picture of the equipment we use to actually carry out the process of filtration. Now, in all likelihood, this is something you've done lower down the school. So what I'd like you to do is in your books do a sketch of the equipment with the labels so you know the key names like the filter paper, the residue, the filtrate, the funnel, etc. And then I want you to try and describe under your diagram what happens in filtration. So I'm going to give you about 4 minutes to get that done. Okay, let's see if we've managed to get a good description here. The first thing we really need to understand for our description to work is what filter paper actually is. Now, filter paper is a special kind of paper that actually has microscopic holes in it. Now, these holes are small enough to allow only small molecules through, not larger ones. So what we find is things like water, they're small enough to pass through these microscopic holes, but anything larger like a piece of mud, for example, then that's going to get trapped and won't pass through. So a really good example of this is sand and water. If you mix those two things together, then pour that mixture into your filter paper. What's going to happen is the sand is too big, it won't go through those microscopic holes on the filter paper, so it sits up in the top as the residue. And then the water is going to be small enough to pass through the microscopic holes, and it goes down into your conical flask as the filtrate. So those are two keywords you need to know: residue, the bit left in the filter paper, and filtrate, the bit that goes through the filter paper and ends up in your collection vessel. If you haven't got those points written down, then I'd suggest you pause the video and get those points written down. I'll leave it up for about another 30 seconds, but if you need longer, as I say, just hit pause. So thinking about what we've just said in terms of our filtration process, have a go at answering the question on the screen. Does filtration remove dissolved substances? And explain your answer. So I'll just give you a minute to write down your answers. So hopefully what we wrote down there is that no, dissolved substances won't be separated out by filtration. They in fact are small enough to pass through the microscopic holes in the filter paper, so they will end up in the filtrate as well. So bear that in mind, filtration doesn't separate out dissolved substances. Our second separating technique that we need to know about is the process of crystallization. Now we're going to use crystallization where we want to get the dissolved substance back. So what we set up, again, I've given you the equipment in the bottom right corner there. So we've got our Bunsen burner sitting under a beaker of water with an evaporating basin sitting on top of it. So what I'd like you to do is have a go at explaining what happens when we heat a solution using that equipment, using those three keywords: solvent, evaporate, and crystal. So I'll give you a couple of minutes to have a go at that. So what we see happening during the process of crystallization is that we're going to be heating up our solution, and when we heat it, then the solvent is going to evaporate, leaving us with crystals of our solute. The reason that we're going to use the beaker of water and not just heat it directly onto the evaporating dish is because we need to do this as a gentle process. If you do this in school, and some of you like to just put your evaporating basins on top of the Bunsen burner and then heat it, particularly when you're getting copper sulfate crystals, then what we find is it suddenly then starts spitting and we make these teeny tiny little crystals that end up everywhere. So by placing it over the beaker of water, it's a gentle process. And what we're actually doing is we're going to heat the beaker of water, and that's going to be boiling away nicely, and that then gently heats the solution in the evaporating dish that sits on top. The solvent from the evaporating dish is going to start to evaporate, and what we see is as the solvent evaporates, then the solution becomes more concentrated, and it's eventually going to end up as a saturated solution. Now, a saturated solution is one where no more solute can dissolve at that temperature, and this is the point that we start to see crystals beginning to form. Then what we do is we turn off our Bunsen burner, and as the solution cools, the solubility of that solute will decrease, and therefore more crystals will form. So what we're actually doing is we're just getting the heating process to get rid of all of the excess solvent, so we have a saturated solution, the crystals begin to form, and then we turn it off, and as it cools down, then its solubility will decrease, so more crystals then form. So make sure you've got those 4 points written down if you haven't already got them. I'd suggest hitting pause on the video if you need a bit more time. I'm only going to leave this up here for about another 30 seconds. So the last stage of our crystallization is actually to carry out filtration, because what we've got are our crystals in the remains of our solution, and we just want those crystals. So what we do is we pour our solution with the crystals into our filter paper, and what we will end up with is the crystals sitting in the filter paper because they're too big to pass through the microscopic holes. The rest of the solution goes through the microscopic holes, and what we do, take the filter paper, place it into a warm oven, and they will then dry out nicely. So make sure you've got those last 2 points down for the process of crystallization. Final thing for today then are the plenary questions. So those of you with target grade up to a grade 5, it's the 2 columns on the left. Those of you with target grades over a grade 5, the 2 columns on the right. So I'm going to leave these up for a couple of minutes. If you think you're going to need longer, obviously you can just hit pause on the video and take as long as you need. As always, you can find the answers to the plenary over on my website, scienceright.weebly.com. You'll also be able to find that under the Internet tab. Just select the week that we're in, and then you'll be able to find things like the lesson PowerPoints, the answers to the plenary, any additional work, and if there's any little experiments I thought you could do at home, then they're there too. So have a look and get using that.